So today we are doing section 1.5. It is the second to last section of the chapter, so we're closing in on the end of chapter 1 here. Remember, we are grading your notes at the end of the chapter, so make sure you're actually taking them. So what you need in your notebook is 1.5, segments and their measures. You do not need the objective in there. So as you're drawing this, as you're writing this, I'm going to draw it for you as well. So this says if you have a point B in between points A and C. So if I have A and C and B's in the middle, then I can take the two little guys, this one plus this one, and that'll give me the whole thing. Okay? So just have that little part. If I have a segment, the little one plus the little one equals the big one. I'm going to add a little something to that. This one is if you're not given the total. So if you're not given the total segment, if you're giving the smaller two, you're going to add. If you are given the total, I would like you to write this as well. If you are given the total, you're actually going to do the big one minus one of the little ones to give you the other little one. Okay? So if you're looking for the whole segment, you add. If you're looking for one of the little segments, you subtract. And I'll give. All right. Here are our first two examples. I want you to go ahead and draw these in your notes. So in the first one, you're given the two smaller segments. Okay? Notice that as you're drawing these. In the second one, do you see how the 25 has like the lines on either side? That's just showing you that 25 is the whole thing. So on number 1, ST, I'm going to trace it in red, starts at S, goes all the way to T. That's the whole thing. When I'm looking for the whole thing, what can I do with the two smaller pieces? Add them together. What is 7 plus 8? It's 15. That's the answer for number 1. Okay? Now, number 2 is a little different because they give us the whole thing. And then they give us a small piece, and they ask us to find the length of the other small piece. What do you think you do here? You're going to subtract. Good. 25 minus 11. So good. 14. Phenomenal. What are your questions? So just real quick, let me show you what it should look like in your notes. So don't draw the state. Just draw 3 points. Call the top one Athens. Call the middle one Macon. Call the last one Albany. You need to know that from Athens to Macon is 80 miles. From Macon to Albany is 90 miles. And I am asked to find from Athens to Albany, question mark. It's just this right here. It's just hung off the board a little bit. So Athens, Macon, Albany. I'm just showing you don't have to draw the whole state. I believe that's Georgia. You don't need the whole state of Georgia to have this in your notes.
Come in.
Very good. I'm going to add 80 and 90. Very good. So everyone always says, when are we ever going to use this? Here's a real life example, okay? If you're traveling between, 3 cities, you stop in the middle, you want to know the length of the whole trip, you just add the segments together.
Why don't you just use GPS?
Or just use your GPS and be a mindless moron the rest of your life. No, I'm just kidding.
GPS is sometimes accurate.
I know, you got to double check that.
And plus, like GPS, almost like double.
How about this? Boom.
Sometimes.
Get there. How about that?
There you go. Okay, couple other things we need to cover. And I don't think you need to write this down because we wrote this down yesterday. I just want to show you real quick. So you already should have this in your notes. When we show that segments are congruent, I just showed you a little of this yesterday, so I just want to remind you again. If they're marked the same way, that is a way to indicate that they're congruent. So those two segments are congruent. If I want to show you that these two segments are congruent, I can mark those two just in a different way. You don't want to mark all 4 of them in the same way because then it looks like they're all congruent. All right, so that's the way we can distinguish one from the other. You could even use 3. Then you could use 2 on this side. Lots of variations here. But if segments are the same length, they're congruent, that's in your notes from yesterday, here's just a way to mark them in a diagram. So you'll see this on tonight's homework. That's why I wanted to go over it one more time today. Okay? Oh, and there they pop in. All right. Last example. Again, you guys can just watch on this one. And then I'm going to have to help you on this one on the homework because it's kind of hard to read. So, we are looking to see if the segments that we're going to graph here are congruent. So I need to graph point A. Point A, I go left 2, up 3. I put a dot, I put an A next to it.
I'll do next one.
Sure.
All right. You go over 3.
Yep.
And you go up 3.
Put a B next to it. Good. Now, if I asked you for the length of that, you could connect them and just count the jumps. 1, 2, 3, 4, 5. That segment is 5 units long. So I want to see if it's congruent to segment CD. Well, how would I graph segment CD? Same way. I go left how many? 3. Then I go up 4. 1, 2, 3, 4. I put a point. I label it with a C. D, I go left 3. I go down 1. Put a point. Label it with a D. Connect those. Count the jumps. 1, 2, 3, 4, 5. Are those congruent? Yes, they have the same measure. And when we show segments are congruent, we write the 2 capital letters with the segment symbol. We write the 2 capital letters again with the segment symbol. The symbol for congruence, we put it in the notes yesterday. It's an equal sign with a squiggle. So a lot of this is a repeater from yesterday, but it's on tonight's homework, so I want to show you. Questions? What did we learn today? Today we learned about what?
Segments and measures.
Segments and their measures. Good. All right, here comes your homework.